This video for Brian Hunter's Lab showing how to get a zero to go across the screen. If you see on the right, this is the data sheet for the LCD screen shown on the Prophase project, and each one of these is a location. So 80 is given us our top left location on the screen. Now this is a 4x16 screen. The LCD I have on the left on the Prophase file is actually just a 2x16, but it's the same concept. We'd be just using 80, 81 and C0 and C1. The 90 and the D0s wouldn't be used. So to have it moving across the screen, this is the code for it. So this is the important code here now. So this within the while loop. So while 1 is indicating while the chip is being powered. This is our declarations of our int, so left to right, and that's location, the hexadecimal location for 80, which you can see here from the data sheet is the top left hand corner. Then we have a right to left, and that's the hexadecimal for the top right, location 8f. And then int I then is our declaration just for a loop. So we also have a write command and a clear command, clear command and then delay. So the way this code works is it goes down through the code, does these commands, and just to clear the screen, and delays for 50,000 seconds, or 50,000, just to allow the screen to clear. And then there's the for loop. Now this for loop's designed so it will go around the counter, and it goes for 15 times because there's 16 iterations on the screen. So it will go from 0 to 15, which is 16 places. And while this does this here, the write command, this write command will take it from the left of the screen. If we step over the code, this will save us going down for each function. These are function calls it's hitting. What this function write data is doing, it is writing the ASCII character for lowercase 0, which is 111, onto the screen. So if you step down through that, and the delay, it'll be on the delay now, so once I jump down it would execute that. But if you look on the screen, the 0 is on and it's just above the RS. So this delay will hold it there so it can come on the screen. Once you step down through that, the while command then the delay is just holding it on the screen. This write command is going to clear the screen, so it will get rid of the 0, and the next line then will be a left to right increment, so it's going to add 1 to our left to right. So at the moment our left to right would be at about 8.4 or 8.5. Whenever I add 1 to it, it's just moving the address by 1 over to the right. So step down through that code. I'll loop back around. It would be doing this 16 times. So if you look at the screen at the moment, there will be nothing written because of our clear screen command. We jump to the right command, and this write data is actually writing the ASCII code onto the screen, but it will be moved by 1 position. And as you can see now, it's moved from above the RS to the RW, showing that it's been moved from one address to the next. And this will continue doing this for 15 times. And that's how we're getting the 0 to go from left to right. As well as that, once it goes left to right, it's going to be stuck then at the address 8F. Now when it's at 8F, we want it to move from the right hand part of the screen to the left. In order to do that, we're just using the exact same for loop, but instead of incrementing, we'll be using left to right, but in this for loop we're using the right to left. But instead of increment it, we're actually decrementing it by 1. So we're moving it from 8F the first time, it'll be 8E, the second would be 8D, 8C, and so on until it gets to 80. That would be the 16 movements of it. So in doing that there, that actually allows us to move our 0 from right side of the screen to the left hand side of the screen. And it'll just continuously do this while the chip is being powered. Once the chip's not being powered, it's actually just turned off and there'll be nothing on the screen shown.